Hello everyone. In this video, we will understand natural hazards and disasters from the exam perspective. First, we will build the basic framework and then we will apply it to India's hazard profile. So, start with the reality check. India is literally a supermarket of disasters. 59% of our land is earthquake prone, 12% is flood prone, and 8% is cyclone prone. Most students memorize these numbers and move on. Toppers do one extra step. They attach each number to a map in their head because UPSC loves location-based elimination. Before we go into hazards one by one, lock this distinction. Many aspirants mix these two words in their answers. A hazard is a potential threat. A disaster is the actual damage. So hazards are geographical. Disasters are socio-economic. Meaning, the same cyclone over an empty coast is a hazard. But over a dense settlement, it becomes a disaster. That one line can upgrade your mains framing instantly. Now comes the mindset shift. The old approach was reactive. Respond after damage. The new approach is proactive. Predict, prepare, mitigate. That's why the flow is shown clearly. Prediction and preparedness lead to risk reduction, and that leads to development. This is the exact causal chain UPSC expects in disaster management answers. Disaster management is not a relief chapter. It's a governance and planning chapter. Now to earthquakes. An earthquake is not random shaking. It is stored stress getting released. The engine is tectonic obstruction. Plates keep moving, but movement is not smooth. Stress builds up. The release is sudden energy discharge. That is the earthquake. The Indian plate is still moving northward at roughly 1 centimeter per year, and that ongoing motion keeps the Himalayan belt active. And here is a hierarchy you should retain. Tectonic earthquakes are far more important than volcanic or landslide-related ones in India. So when the question is about India's major earthquake risk, start with tectonics, not surface symptoms. Now map the shaking. India's seismic zones are not just colors on a map. They reflect structural geology. Zone 5 is very high risk. Zone 4 is high risk. Zone 3 is moderate risk. Zone 2 is low risk or stable shield. The pattern is the real point. The young fold mountains, Himalayas and much of the northeast fall in the highest risk belts. The stable shield region, especially the Deccan Plateau, is far safer. This is a classic prelims trap. There is no Zone 1. And this is how toppers revise it. Young mountains mean unstable crust. Stable shield means lower seismicity. Now let's define tsunami properly. Tsunami is a harbor wave, meaning a sequence of waves, not a single wave. Its trigger is undersea plate displacement. That's why out in the deep ocean, it can travel at high speed like a jet plane. But near the coast, it turns into a high-amplitude wall of water. And the impact line matters for India. The 2004 Indian Ocean tsunami birthed the warning system. So whenever you write tsunami, connect it to early warning systems, not just wave mechanics. Now we move to tropical cyclones, basically nature's heat engines. The structure is important. There's an eye, which is calm, low pressure, and cloudless. Around it is the eye wall, where maximum destruction happens. And the air movement is shown clearly. Warm moist air rising, outflow at the top, and subsiding warm air with descending cool air around. Now the ingredients are the scoring part. 1. Sea surface temperature must be more than 27 degrees Celsius because that's your latent heat source. 2. Coriolis force to spin the air. 3. A pre-existing weak low-pressure area. Here's a trap you need to be aware of. No cyclones at the equator, roughly 0 degrees to 5 degrees, because Coriolis force is 0. Now, a very India-specific question. Why does the east coast see more cyclones than the west? Bay of Bengal is shallow, has warmer water, and its funnel shape captures storms. That's why the map highlights higher frequency, especially in October to November. Arabian Sea historically had lower frequency, but the recent increase in activity is seen due to climate change. And the major threat line is crucial. Storm surge, meaning abnormal sea level rise. Students talk only about wind speed. UPSC often tests storm surge because that's what actually kills along flat coasts. Now floods. And notice the flow given here is exam useful because it shows causation. Heavy rainfall plus deforestation leads to siltation of riverbeds and then water overflows banks. Now the impacts are split cleanly. The destruction side. 40 million hectares are prone, diseases like cholera and hepatitis rise, and hotspots include Assam in the Brahmaputra basin and Bihar in the Kosi basin. But floods also have creation. They deposit fertile silt. And the example given is Majuli Island in Assam and paddy crops. This balanced framing is how you write a mature mains answer. Hazard plus benefit plus management. Now drought, the slow disaster. India has 19% drought-prone area. And drought is not one type. It has 4 forms. And UPSC loves this classification. Meteorological drought is simply rainfall deficiency. Agricultural drought is when crops fail due to lack of moisture. Hydrological drought is when surface and groundwater levels fall. Ecological drought is the large-scale ecosystem impact. If you can write these 4 in one line with a crisp example, your disaster management answers become sharp. Now map drought vulnerability. Western Rajasthan is marked extreme. Kutch and Gujarat are prominent. Parts of Madhya Pradesh and Andhra Pradesh show severe vulnerability. And the monsoon irony is written clearly. Simultaneous floods in Assam and drought in Rajasthan. And the chain of consequences is important. Crop failure leads to fodder scarcity, which leads to human migration. This is where you show maturity. Drought is not only climate, it is livelihoods. Now landslides, gravity's toll. 2 high vulnerability regions are highlighted. The Himalayas due to unstable geology and tectonics. The Western Ghats due to steep slopes and heavy rain. Here's the differentiator you must retain. The Himalayas are tectonically unstable. The Western Ghats are not. That one line helps you explain why Himalayan landslides can be more frequent and complex. Now mitigation, the first line of defense. Structural mitigation. Floods, levees and bunds. Tsunami and cyclones, sea walls. Drought, check dams. And then the warning that UPSC expects in governance answers. Risk of defense failure. When structures break, damage is often worse than the natural event itself. And the legal anchor given is critical. Disaster Management Bill 2005. In mains, this becomes your institutional hook. Now the disaster management cycle. And this is the framework you should write in mains without hesitation. Pre-disaster includes prevention, mitigation, preparedness, and zoning maps. During disaster, it includes response, evacuation, and relief. Post-disaster includes recovery, rehabilitation, and reconstruction. And the central message is the shift from relief-centric to prevention-centric. This is the difference between average answers and high-scoring answers. Now we close with consolidation. Earthquakes, zones 2 to 5. Tsunamis, warning systems. Cyclones, east coast vulnerability. Floods, rain plus silt. Drought, 4 types. Here's your homework. Take a blank map of India and mark seismic zones, cyclone-prone coasts, major flood basins, and drought belts. Visual memory is your best weapon. If you can draw vulnerability from memory, you are ready for prelims.